about rate of change as a problem first, though. And think about the idea if you're on this water slide and you go down at this kind of a slope, this is time and this is distance, right? And you're at 76 feet. You're going to go fairly slowly down your ride, right? If your slope looks like this, you're going to go pretty quickly down, and that slope is steeper and this slope is less steep, and the slope, which will be the change in the rise over the change of the run, will be greater than in a more horizontal one. So I just want you to think about that whole big idea picture about what slope means and what slope looks like. All right, vocabulary. We're going to do rate of change, which is right here on this page, and then slope we'll do in another slide in just a second. But first, let's talk a little bit about some review vocabulary. Rate. Rate is a ratio, right? It's comparing two numbers. In this case, we're going to compare y to x. Independent variable and dependent variable. Independent variable is a variable of choice. Dependent variable means it depends on the value of the independent variable. So rate of change is a ratio that describes how much one quantity changes compared to the other one. So in a formula, it looks like this. Rate of change, the rate something changes, is equal to the change in y over the change of x, where y is the dependent variable, let's change that, and x is the independent variable. So let's just look at this slide, and I just want to show you that this shows rate of change in our theme park attendance, and you'll notice that from 2000 to 2000, oops, come back here. From 2000 to 2002, there's a certain slope or a certain increase in attendance. And then look what happens to the slope. It changes between 2002 and 2004. In this case, it is not a constant rate of change. The rate of change actually varies. With a linear equation, if it were a straight line graph like that, then the rate of change would stay constant. So just note the difference between a constant rate of change and a rate of change that is not constant and what that means. This would be to say that the sales went up. The blue line would say that the sales went up every year the same amount. Is that true? Not necessarily. You know, it's true this time, but in our red line it shows that it changes year to year, how it goes up. Okay, so this is my point that I wanted to make on that last slide, right here, in yellow. Linear functions have a constant rate of change. So the rate of change, let me see if I can get a pencil here, on this purple dashed line, right, is, looks like it's moved. If I go over 2, I go up 1. If I go over 2, I go up 1. If I go over 2, I go up 1. If I go over 2, I'm up 1. That's a little bit off on the projection with the graph, but you can see that that's basically true. How far you go over stays consistent and is at the same ratio of 1 to 2. This is the y, this is how far you're going up, and this is the x, how far you're going over. So all linear functions have a constant rate of change. It isn't different. A positive rate of change indicates an increase over time. So if you look at our purplish, bluish line, this line right here, going to here, that is a positive, that indicates a positive rate of change, that over time we're making more and more and more and more money, all right? Then a negative rate of change, here we have a negative slope on the green line, and that indicates that we're losing money over time. We started with this much money and we're about to run out of money. Okay. So we can look at rate of change in tables, and you can look at a table and you can decide whether or not the function is linear. So here we have a table of a function, and we have to determine whether or not it's linear. And the way we would do that is we would look at the change in y over the change in x, all right? So in this case, if we look at the difference between -8 and -6, we get something, and we look at the difference between 4 and 1, and that's exactly what they've done down here. -8 minus a -6 is 2, and 4 minus 1 is 3. It's actually in -2. So our rate of change is -2 over 3. And if we do that with each pair of numbers, if we then look at 8 and 10, and then go look at 10 and 12, and then go look at 12 and 14, we'll see that the rate of change between the y values and the rate of change between the x values, the y values are on top here, always is 2, isn't it? And the rate of change of the x values, which are down here, oops, sorry, didn't like me doing that. Come back. Thank you. Will let me write yet? Okay. The x values, which are down below, you can see are always 3. So what and now if we look at this table here, sorry, my new software's, I'm getting used to, guys. Sorry, don't mean to mess you up here. Oh, come on, stop it. Okay. If you look at our x and y value over here on this table, you'll see that the rate of change varies. Between 10 and 12, it's 1. And between 12 and 16, it's 2. And then it goes back to 16 and 8, it's 1. And then it's back to 2. So this is not a linear function because the rate of change is not consistent. I'd like you to try these two problems, subtract, and let me just get you started. So you're going to see the rate of change over in the y over change in the x. What's the difference in the y values? What's the difference in the x values? So to get started, I would say 15 minus 11, those would be my y values, right? And my x values would be -2 minus a -3. And we get 4 over plus 1. So that's the change to this one. Is it the same? Does it change the same way when I go from compare 15 and 19? 19 minus 15. Okay, you guys do the rest, okay? Don't worry if you don't get these. We'll go over these in class a little more. Try them, though. All right, slope. Slope we've had before. Should go pretty easily for you guys. Slope is, let me move this screen recording out of the way. Slope is, where are you going to go? Slope is the ratio of the change of the y coordinates and the x coordinates, all right? So there's your definition of slope. Change of the y coordinates and the x coordinates. And you'll remember that we used to think of that, well, we'll talk about that in the next slide. But what I'd like you to look at is think about the steepness of the line. The greater the absolute value of the slope, so consider this slope right here, right? The steeper I make it, the greater the absolute value. The less steep I make it, the less the absolute value, okay? And we'll look at that a little bit further here in a minute. All right. So slope is rise over run. Do you remember that from last year? So here we have our rise is how far we go up this way, right? And our run is how far we go that way. Rise is vertical, horizontals is the run. And what we're going to do is we're going to look at the change in the y coordinates. So the y coordinates is -2 and 3. So we're going to look at -2 minus 3, And then we're going to look at and it's over the change in the x-coordinates. The x-coordinate is 2 and -1, so 2 minus a minus 1. So our slope is -5/3. We're going to do a couple more problems, so just to sort of take that idea in of what slope looks like. All right, and here's a chart that helps you remember this. Remember, we always referred to slope as m. M equals subtracting the y coordinates. Here we have y sub 2 and y sub 1, right? And x sub 1 and x sub 2, okay? We're going to subtract y sub 2 minus y sub 1. That's going to be our change in x over x sub 2 minus x sub 1. That's going to be our change, excuse me, top is our change in y and the bottom is our change in x. So slopes can be positive, negative, 0, undefined, and we're going to look at those in just another slide. But you'll remember that if it's going up this way, it's plus, and over here it's minus. We'll talk about it in a minute. Make a note. Read this about how you read y sub 1 is read as y sub 1 and x sub 2 is read as x sub 2. And I would like you to use the appropriate lingo. Okay, let's try a few of these. So we have 2 points. We have the point -2, 0, which is here, and the point 1, 5. And we're going to find the slope of the line that connects those 2 points. So we'll say m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I always like to label my points x sub 1, y sub 1, x sub 2, right, y sub 2. Okay, so y sub 2 is 5, so m will equal what? 5 minus 0, y sub 1, over x sub 2, which is 1 minus a minus 2. Plus down here, so I get 5/3. So the slope of this line is 5/3. That means I go up 5 and over 3. Up 1, 2, 3, 4, 5. This is 5 and over 3. Let's look at another one. -3, 4, and 2, -3. Here's -3, 4, and 2, -3. Okay, m equals, let's label our points for x sub 1 and y sub 1, x sub 2 and y sub 2. Takes a second to label that point, but it's really worthwhile. It really keeps you from making careless mistakes. So we're going to go y2 minus y1, so that'll be -3 minus 4 over 2 minus a minus 3. Plus, we get -7/5. And that means this is 7 up 7 and over 5. Sorry, bad writing. Okay? And it's a negative slope. It's going up to this corner, and we'll talk about that in a minute. Here's another one. -3, 0. We have a horizontal line, you'll notice. Let's see what that slope looks like when we calculate it out. x1, y1, x2, y2, right? So y2, -1 minus a minus 1 over 2 minus a minus 3. Plus, -1 and a plus 1 is 0 over 5. So any number, 0 divided by any number is 0. So this slope is 0. And that's what we if you're asked if it's positive, negative, 0, or undefined, this one, horizontal lines are 0. Okay, do the 3 practice problems that are highlighted in yellow. And if you're ambitious, try another 1 or 2. Find the slope of the line that passes through -2, 4, and -2, 3. Okay, looks like we have a vertical line here, doesn't it? Okay, well, let's do the calculations on this. x1, y1, x2, y2. And we're going to go m, the slope is going to be equal to -3 minus 4 over -2 minus a minus 2. Minus, plus, we get a -7/0. Can you define any number by 0?